All right. So this video is for students that are doing the perfectly inelastic collisions. All right. So you want to remember which sensor was which. So hopefully you labeled them. If not, go back and do that process again so that you know that this sensor is for cart 1 and this sensor is cart 2 or whatever, vice versa, depending on how yours is set up. Then for perfectly inelastic collisions, you want the Velcro sides facing each other, and you need to make sure that the spring is not sticking out. Okay, this little spring-loaded component is not popped out. So you push the button on the top, you move it in. Sometimes it gets stuck like that. You have to go all the way in until it's flush. Okay, so it's not sticking out at all. If you struggle with that part, I will come around and help you. So don't worry about that. Now, the next bit, I'm going to do my best, okay? But getting this to start, you have to hit start, and then you're going to move them towards each other. Or maybe we just have you move one. Yep. Yeah, so you could move them both towards each other, so that's fine. Or you could just have one, but I'm going to move them both towards each other for mine. I already have data on the screen, and I don't like that data there because it can confuse me. I don't remember which one's which. So once I get my cursor back to this screen, I'm going to delete it. And this is why I had you save as, not save over, okay? Because sometimes students delete the whole cart, and getting it set back up is really quite a challenge. So try to just delete the runs. Run 1 and 2 aren't showing up, so I'm just going to leave them there. All right, then I'm going to click Start and quickly push these together. So move them apart, a little further apart to start for now, and then let it be. I'm going to click Start and move them, and then there we go. All right, and it should stop on its own, but it doesn't appear to be stopping, so let's hit stop. All right, so now I'm going to move this closer to me so that I can see it and do things a little more easily. So let's see here. All right. So this is the part of the graph I like. This part over here was after the collision, and then I think that I was trying to get in the way, so maybe the sensor picked up me. Who knows what? But this is where we're looking, and I'm going to go ahead and zoom in. All right. So did you see that? You need little squiggly lines like that if you want to zoom in. That was an accident, so I'm canceling that. All right, so you can zoom out and you can zoom in. Okay, you could also do it over here. Move it over if I want. Okay, and you could do the same thing along these ones to zoom and to move over. But for right now, this is how I like it. All right, this one's a little confusing because I got dark green and light green, but this one has dots. This one has a plus. So the one with the plus is cart 1, and cart 1 for me was the red cart. So the red cart's velocity before the collision is, it says 0.5, and then this would be 0.52, 0.54, 0.56, 0.58, and then 0.6. If it helpful, just think 50, 52, 54, 56, 58, 60, okay? And then just put a decimal in front of them. So this was moving at about 0.5. If I wanted to zoom in a little further, maybe I could. Maybe it's close to. So right before the collision right here, I'm going to say it's right around 0.5. So I'm going to say my red cart is moving at 0.5 meters per second, and I'm going to write that down on the before side of my data table. Then my blue cart is down here. This is a little bit more wobbly, but it looks kind of like it's right in here for the before, right before the collision. So I'm going to go over. That's 0.3. That's 0.4. It's kind of maybe 0.36, and it's negative. So for the blue cart, I'm going to write my velocity was negative 0.36. And then I'm going to go ahead and find the mass of each of these because we needed the mass on our data table, and I didn't have that. So for the mass, you're going to walk these over, put them on the scale, and then walk them back. And remember which one was which. The red was on this side, the blue was on this side, so that you're consistent, okay, with your rest of your trials. And then I need the total mass for afterwards. Just add the two masses that you got together because they're stuck together now. And then you need the velocity for afterwards. And if you look, despite the fact that there's not a lot of friction on this track, they definitely slowed down. I need to take the velocity right afterwards. Okay. So I would go and take this velocity right after they collide, which is about 0.8, and it's positive. So I'll add their masses, put it in the mass together, put 0.8 in for the velocity afterwards. And then I'm going to go, and for trial one, I do my calculations. I figure out what was the momentum before, the total momentum. So the momentum of the red, the momentum of the blue, I add them together, get my total momentum. Then I figure out the total momentum afterwards. Okay, use their mass together, their velocity, find the total momentum afterwards. And then I'm going to compare that data in a little bit. Okay. Then I need to figure out the kinetic energy. So I figure out the kinetic energy before for the red, the kinetic energy before for the blue, and then the kinetic energy of them afterwards. Okay. And then I'm going to compare that data. Then you're ready for trial two. Trial two, you're going to repeat, but when you do trial two, we are going to put 500 grams on one of the carts. It doesn't actually matter, but I may write it down in your paper. So I think it's the blue one. So you're going to put a 500 gram mass on top of here and do the same thing. Get your data, do your calculations. And then for the third trial, you're going to have two 500 gram masses, so a total of 1,000 grams extra, and do the trial and do it again. Okay. And for each of those, you're finding the same different pieces of data, and then we'll present on that later. So perfectly inelastic, you guys should now be ready to go.